Welcome to the deep dive. You're likely here because, well, you want to get up to speed quickly, really understand something important without getting totally overwhelmed. Today we're tackling something pretty core for anyone working with JavaScript. Refactoring and modularization, taking that code you already have and making it clearer, more efficient, and honestly just easier to maintain down the line. Exactly, we hear this a lot, right? People wrestling with these huge JavaScript files. Oh yeah, maybe you've got an off.js or a main.js. It's crept past, 1,000 lines, maybe more. Happens easily. So think of this as your shortcut. We're going to distill the key ideas of practical steps to take a tangled code base and make it well manageable, maybe even enjoyable to work on. Okay, so let's start there. Why are these massive files such a problem? Our source is really laid out. Well, the first big one is just cognitive complexity. Your brain trying to hold the context of thousands of lines? It's really hard. It's like trying to read a novel where every character and plot point is on a single, enormous page. Yeah, you just lose track. You do. And that leads to real tangible issues, like name collisions. Where you use the same variable name so we're completely different, and suddenly things break in weird ways, those head-scratching bugs, you know? Definitely. And just maintaining it becomes a slog, finding one bug. It's tedious, like finding a needle in a haystack, isn't it? Totally. It's not just you working alone, right? What about teams? Oh, teamwork really suffers. Imagine 2 or 3 people trying to edit that same monster file. Merge conflicts constantly. You're all the time. You're stepping on each other's toes. It slows everything down. Plus performance, right? Bigger files mean more for the browser to parse, longer load times. Yeah, it impacts the user experience directly. Sluggish apps aren't fun. And the last point, which is huge, testability. Yeah, testing becomes incredibly difficult. When everything's tangled together, how do you test one small part in isolation? You can't easily. You end up testing huge chunks, which isn't really unit testing anymore. Exactly, it's inefficient, and doesn't give you much confidence. Okay, so we've established the pain. Big files, bad. How do we fix it? Refactoring, and the guiding principle seems to be separation of concerns, or so-so. Great. Sounds a bit formal maybe, but the idea is simple. Yeah, each piece of your code, each module should do one specific thing, have one responsibility. Like organizing a toolbox, screwdrivers here, hammers there. Precisely. It just makes everything easier to find and manage, reduces that mental load we talked about. So for our Notes app example, what would that look like? Okay, think about the jobs involved. User login and sign up. That's one clear concern. Right, authentication, then actually managing the notes, creating, saving, deleting them, that's another distinct job, notes management. Makes sense, how those notes look on the screen, the UI part, that's separate again, and then maybe how the app handles its data internally or saves things to the browser's local storage. Each of those is a specific concern. So you don't want your login code mixed up with your note display code, definitely not. That entanglement is what we're trying to fix. And that connects to cohesion and coupling, doesn't it? It does. High cohesion means the stuff inside one module is all tightly related, all focused on that single job. Okay, like everything in the off module is just about off. Exactly. And low coupling is about how modules interact with each other. You want them to be as independent as possible. Why is low coupling so important? It makes your code resilient to change. If modules depend heavily on each other's internal details, a change in one breaks others. Bingo. Low coupling means you can change or update one module without causing ripples everywhere else. It's about future-proofing. The source mentioned a save new note. Let's look at a function example. So how does that actually illustrate this? Right, so imagine that one function did everything. It would grab the text from the input field, check if it was valid, and then write it directly to local storage. Okay, that seems efficient maybe, but it's tightly coupled. It knows about the UI input, the validation rules, and the storage method. So, if you wanted to change how storage works, like maybe save to a server instead, you would have to rewrite that one function even though the UI part didn't change, and you risk introducing bugs. So, The aha moment is breaking it down. Exactly. One piece for UI interaction, another for validation, and a separate one for actually saving the data. They talk to each other, but they don't need to know the internal messy details of the others. Okay, that makes sense. Now, solid principles also came up. We don't need a whole lecture, but which ones are most relevant here? Well, the single responsibility principle, SRP, is basically saucy again, isn't it? One module, one reason to change. Right, if your auth module only does auth, you only change it if author requirements change. Precisely. Not because you tweak the noteless styling. Makes sense. What else? The open-close principle is interesting. It says you should be able to add new features without changing existing code. How does that work? Magic. Not quite. It's about designing things using abstractions like interfaces. You extend behavior rather than modifying the core. Think plugins. Okay, extending, not rewriting, and dependency inversion. DIP. This one's key for that low coupling. It suggests relying on abstractions, not concrete details like the power outlet example. Your code, the lamp, just needs the standard interface, the outlet. You don't care how the power plant generates the electricity. Okay, so modules depend on stable interfaces, not specific changeable implementations. Exactly. Makes things way more flexible and testable because you can swap out implementations behind that interface. Alright, principles understood. How do we structure the app? The source mentions MVC, MVVM, but recommends a flat modular architecture for this Notes app scenario. Why that one? Well, MVC and MVVM can be great, but sometimes they bring more structure than you need, especially for simpler apps. A bit heavyweight maybe, could be. The flat modular approach gives you that core benefit separation by function or feature, without necessarily enforcing a strict MVC pattern. It's often simpler to get started with. So, independent modules are grouped by what they do, off Notes UI, and, the crucial part is really how they communicate, right? Not calling each other directly, ideally no. To keep that coupling low, they often communicate indirectly using events or like a central message bus. Like that Office memo board analogy you mentioned. Exactly. The Notes module finishes saving and posts a Notes saved event. The UI module is listening for that event and updates the screen. So Notes doesn't need to know how UI displays things, just that it needs to be updated. Precisely. That loose coupling is the real win here. It makes things so much easier to change later, and it helps avoid those name collisions too. Because things are contained in their own modules, their internal names don't clash globally. Big advantage. So let's visualize this. What does the folder structure look like? The source gave us a specific example. Yeah, it's quite intuitive. You typically have your main code, maybe an app.js, and inside that, folders named after the concerns. Auth notes maybe utools for shared helper functions, so auth would have login.js, signup.js, maybe user service.js, exactly. And notes might have note store.js for data logic, noteless.js for display logic. Who could have things like components button.js or modal.js? You got it. The structure itself tells the story about how the application is organized. It becomes self-documenting in a way, much easier to navigate than one giant file, night and day difference. Okay, structure makes sense. Yeah, how do we get there from our current massive auth.js and main.js? What's the plan? Step 1 is often just creating those empty folders, mk, dir, app.js, auth, etc. Sounds basic, but it's the foundation. Can't organize without shelves, right? Pretty much. Step 2 is the analysis. Go through those big files and identify the different responsibilities hiding inside. So reading the code and saying, okay, these lines are about login. These lines handle displaying notes. Exactly. Mapping the existing code to your new module structure, applying that separation of concerns thinking. What's a common hurdle there? Sometimes code is really tangled, isn't it? It absolutely can be. You might find a function doing 3 different things. The key is to start small, identify the main purpose, and be prepared to break functions apart later if needed. Don't aim for perfection immediately. Okay, good advice. Step 3 is actually moving the code. Yeah, extracting those identified chunks into the new files, like taking all the user registration code from auth.js and putting it in authsignup.js. and the data handling for notes goes into notes.store.js, separate from the UI. Right, you start physically separating the logic. Then step 4, that event bus we talked about. Yeah, implement a simple publish-subscribe system. The source likely gave a basic code example. A way for modules to broadcast messages like user login or new note added, and other modules can listen and react without direct calls. This replaces global variables too. It should, ideally. It's a much cleaner way to handle cross-module communication. Okay. And step 5, entry points. Right, you need a main file, maybe index.js or app.js that imports the necessary modules and kicks things off. Like the example, using DOM content loaded to wait for the page to load, and then it might initialize the auth module, set up the UI listeners, load initial notes, that kind of thing. It coordinates the startup. Got it. And, modern JavaScript's import and export are key here, aren't they? Absolutely essential. They provide several big benefits for this modular style. First, scope to logic. Variables and functions inside a module are private by default. No accidental global clashes unless you explicitly export it. That helps prevent those weird bugs. Massively. Second, clear dependencies. The import statements at the top of a file tell you exactly what other modules it relies on. Makes the codebase structure much easier to understand. Totally transparent. Third, easy code reuse. Write a utility function once, export it, and import it wherever you need it. Nice, and testing, much simpler. Because modules are self-contained and you control their dependencies via imports, you can test them in isolation more easily. Mocking dependencies becomes straightforward. Okay, so import-export are fundamental tools. What about keeping things understandable long-term? Documentation and naming, hugely important, especially as the code base grows or teams change. Good naming and docs save so much time. The source mentioned JS doc. Yeah, using those special comments to describe what functions do, their parameters, what they return, it helps tools generate documentation, and it helps humans understand the code just by reading it, like inline documentation. Exactly. And consistent naming conventions help too, like camel case for functions and variables, Pascal case for classes, and using clear verbs like getNote, saveUser, renderList. Those little consistencies add up to make the code much more readable and predictable. It reduces cognitive load again. Are there tools that help enforce this stuff? Oh yeah, absolutely, the ecosystem is great here. ESLint is huge for catching code style issues and potential errors automatically. You configure rules and it tells you when you break them. Yep, and Prettier is fantastic for just automatically formatting your code to a consistent style. No more arguments about tabs versus spaces. Always a classic. JS doc tools can generate actual documentation websites from your comments and Get, of course, indispensable. How does Get specifically help refactoring? Feature branches. Do your refactoring on a separate branch. If it goes wrong, you can just discard it. If it works, you merge it safely. It removes the fear factor. Makes sense. The source also mentioned Webpack or Parcel, optional. Yeah, those are module bundlers. For a really simple app, you might not need them initially if you're using native ES modules, but as the app grows, they become super useful for optimizing your code for production, handling different asset types, enabling features like hot module replacement during development. They're often a next step as complexity increases. Makes sense. The source also mentioned Webpack or Parcel, optional. Yeah, those are module bundlers. For a really simple app, you might not need them initially if you're using native ES modules, but as the app grows, they become super useful for optimizing your code for production, handling different asset types, enabling features like hot module replacement during development. They're often a next step as complexity increases. Okay, the source also included a communication diagram. How does that help visualize things? It just ties it all together. It shows those main modules, off notes UI, and how they interact, typically through that central point, the event bus or app controller. So you see lines going to the bus with events and lines coming from the bus to the listeners. Exactly. It visually reinforces that idea of indirect communication and low coupling. It shows the flow of information without showing direct dependencies between the core feature modules. It drives home that it's not just about file structure, but about the interaction patterns. Precisely. The structure enables the pattern, but the communication pattern is key to the benefits. Alright. So bringing this all together as we wrap up this deep dive, what's the main takeaway message? I think the source summed it up nicely. Modularization isn't just splitting files, it's fundamentally about organizing your code by its responsibility and the payoff. Better maintainability, easier to fix bugs, easier to understand, better reusability, components can be used elsewhere, and better scalability, the system can grow more gracefully. It makes sense. It's an investment that pays dividends down the road. Absolutely. It might feel like a bit more work up front, but it saves so much pain later. So a final thought for our listeners building on this. Yeah, think about your own code bases right now. Is there one part maybe that oc.js or a particularly complex feature that feels like a tangled mess? Where could you start applying these ideas? Exactly. Which part of your code could benefit most from this modular approach? Just identifying that first target can be the most powerful step to actually starting.